Good day, students. Welcome to mathematics video for M.1. The topic for this video is all about indices and law of exponents. In this topic, students will be able to define indices and exponents. Students will be able to learn different laws of exponents. Students will be able to apply the laws of exponents in any computation involving indices. Let's discuss first about indices and exponents. The plural form of the word index is indices, and index can also be called exponent. Exponents are a given quantity representing the power to which a given number or expression is to be raised. The big number 5 is the base number which tells what number is being multiplied. And then, the exponent tells how many times the base number is being multiplied. The whole expression is also called a power. How do we read an exponent? A number with an exponent is said to be raised to the power of that exponent. 3 raised to the second power, or 3 squared. 5 raised to the third power, or 5 cubed. 7 raised to the fourth power, or 7 raised to the power of 4. Let us learn about the laws of exponents. Before we go through the next topic, remember that a number in exponential form has a base and an exponent. The exponent indicates how many times the base is used as a factor. And the laws of exponents are a way to show how to simplify expressions in exponential form. First, product law. To multiply powers with the same base, we have to add the exponents. It could be shown as a raised to the power of m multiplied by a raised to the power of n equal to a raised to the power of m plus n. For example, 4 cubed multiplied by 4 raised to the power of 4 is equal to 4 raised to the power of 3 plus 4 equal to 4 raised to the power of 7. Let's prove our answer. Expanding 4 cubed multiplied by 4 raised to the power of 4, we will have 4 times 4 times 4, open and close parentheses, multiplied by 4 times 4 times 4 times 4, open and close parentheses. We have 7 4s multiplied with each other, and we can shorten that by writing 4 raised to the power of 7. Second, quotient law. To obtain the quotient of powers with the same base, we have to subtract the exponents. This could be written as a raised to the power of m over a raised to the power of n, and could also be written as a raised to the power of m divided by a raised to the power of n, equal to a raised to the power of m minus n. Let's have an example. 2 raised to the power of 5 divided by 2 squared. By following the rules, we will have 2 raised to the power of 5 minus 2 equal to 2 cubed, or 2 raised to the power of 3. Let's prove the result. Expanding the expression, we have 2 multiplied by itself 5 times over 2 times 2. We cancel the numbers that could be paired, and we have 2 times 2 times 2, and which we can write as 2 cubed. Power of 0. For the law of zero exponent, any non-zero number raised to the power of 0 is equal to 1. We can show it as a raised to the power of 0 is equal to 1. Let's have an example. 2 raised to the power of 5 divided by 2 raised to the power of 5. By following the quotient law, we will have 2 raised to the power of 5 minus 5, and which is equals to 2 raised to the power of 0, equal to 1. Let's prove. We have 2 multiplied by itself for 5 times over 2 also multiplied by itself 5 times. We cancel out the pairs, then it will be equal to 1 multiplied by itself 5 times. No matter how many times you multiply 1 by itself, it will always be equal to 1. Power law, or power raised to another power. To simplify any power raised to another exponent, we multiply the two exponents. We could write it as a raised to the power of m and raised to the power of n, equal to a raised to the power of m multiplied by n. Example: 4 cubed squared, or 4 raised to the power of 3 and then raised again to the power of 2. By following the law, we have 4 raised to the power of 3 times 2, equal to 4 raised to the power of 6. Let's prove the answer. 4 cubed and then squared can be expanded as 4 cubed multiplied by 4 cubed. By expanding it again, we will have 4 times 4 times 4, open and close parentheses, multiplied by 4 times 4 times 4, open and close parentheses. As we can see, we have 4 multiplied by itself 6 times. We can shortly write it as 4 raised to the power of 6. Power of a product. To find the power of a product, find the power of each factor, then multiply. We can show it as a multiplied by b enclosed in a parenthesis raised to the power of m. We distribute the exponents, we will have a raised to the power of m multiplied by b raised to the power of m. Let's have an example. 4 multiplied by 2 enclosed in a parenthesis raised to the power of 4. By following the law, we have 4 raised to the power of 4 multiplied by 2 raised to the power of 4. We expand the expression. We have 4 multiplied by itself 4 times, multiplied by 2, which is multiplied by itself 4 times. We calculate, and then we have 256 multiplied by 16. The final answer is 4096. Power of a quotient. To find the power of a quotient, raise both the numerator and denominator to that exponent. This could be written as a over b enclosed in parentheses raised to the power of m, equal to a raised to the power of m over b raised to the power of m. Let's have an example. How to simplify 2/3 squared. By following the law, we will have 2 squared over 3 squared. Expanding the expression, we have 2 multiplied by 2 over 3 multiplied by 3. The final answer would be 4 over 9. Negative indices. Negative indices are all exponents or powers that have a minus sign in front of them. This could be written as a raised to the power of negative n equal to 1 over a raised to the power of n, and 1 over a raised to the power of negative m equal to a raised to the power of m. Let's clarify the second expression. 1 over a raised to the power of negative m would be equal to 1 over 1 over a raised to the power of m. If you could recall the rule of dividing fractions, we will have 1 multiplied by a raised to the power of m over 1. The result would be a raised to the power of m. Now, let's have an example. 2 raised to the power of negative 4 this could be equal to 1 over 2 raised to the power of 4, which is equal to 1 over 16. We could flip the process. Example, 1 over 7 raised to the power of 6 is equal to 7 raised to the power of negative 6. Another example, 1 over 5 raised to the power of negative 3. This will be equal to 1 over 1 over 5 cubed. Following the rule of dividing fractions, we have 1 multiplied by 5 cubed over 1, and this will be equal to 5 cubed. And for the final answer, we have 125. Fractional indices. A fractional exponent is an alternate notation for expressing powers and roots together. We write the power in numerator and the index of the root in the denominator. This could be shown as a raised to the power of m over n equal to n root of a raised to the power of m. Before we have an example, let's go through first on the parts of a radical expression. First, we have the radical symbol. This symbol is indicating extraction of a root of the quantity that follows it. Next, we have the radicand. This is the quantity under the radical symbol or sign. And lastly, the index. If there is no index number written, then it is understood as 2. Now, let's have an example. A raised to the power of 3/4 is equal to 4th root of a cubed. Let's have another one. B raised to the power of 6/2 is equal to square root of b raised to the power of 6. It could be also the other way around. Square root of a raised to the power of 5 is equal to a raised to the power of 5/2. 4th root of a raised to the power of 7 is equal to a raised to the power of 7 over 4. One more example. 625 raised to the power of 1/4 is equals to 4th root of 625. And the answer is 5. We can prove the answer by multiplying 5 by itself 4 times. It will be equal to 625. That would be the end of this video. I hope you have learned a lot from this topic. Thank you for watching.